Hello friends. Hello friends. To discuss about the subject processor architecture, the second unit pick interrupts and interfacing, in which the point of discussion is the interrupt and a pooling. What is the interrupt? An interrupt is an event that indicates the microcontroller to take immediate action. There can be an interrupt to indicate the timeout of a timer. Additionally, an interrupt can notify the received data pack of a networking device. When an interrupt occurs, the microcontroller pauses the task it is currently executing and execute the corresponding interrupt handler, which is known as an interrupt service routine (ISR). After handling the interrupt, it switches back to the usual task it was executing. So now next point is what is the polling? Polling is a mechanism that indicates the microcontroller that a device requests its attention. It is a continuous act to figure out whether the device is working properly, as it is mostly used with a input output. It is called a polling IO or software driven IO polling. Also help to check a device continuously for readiness. For example, take a printer. If a device is busy, the microcontroller performs some other task. Usually, polling after involves the low-level hardware. So, we'll find out the difference between the interrupt and the polling. So, interrupt is an event that is triggered by the external component other than the microcontroller, that alerts the microcontroller to perform the certain actions. In contrast, polling is a synchronous activity that samples the status of the external device by a client program. Thus, this describes a main difference between an interrupt and a polling. When an interrupt occurs, the interrupt handler is executed. On the other hand, in the polling, the microcontroller provides the service. The interrupt Another difference between the interrupt and a polling is that the interrupt can occur at any time, while a polling can occur at a regular interval. Moreover, the interrupt request indicates that a device needs a service, whereas a command ready bit indicates the device needs a service. Interrupt does not waste many CPU cycles, whilst the polling wastes a lot of the CPU cycles. Hence, this is also a difference between the interrupt and a polling. Furthermore, in case of the interrupt, it is inefficient when a device interrupts the microcontroller frequently. Okay, because it is a current execution of the process has to stop, and attention of the CPU goes to the interrupt handlers. So this will not a good idea. So in contrast, the polling is inefficient when microcontroller does not get such a request from a device. A microcontroller in the polling mode periodically observes for a device if there is any request from any device. Okay, so this will waste a substantial amount of the CPU cycles if a device does not have any request. The main difference between the interrupt and the polling is that in the interrupt, the device notifies the microcontroller that it requires attention, while In a polling, the microcontroller continuously checks the status of the device to find whether they require attention. In brief, an interrupt is a synchronous or asynchronous, whereas the polling is a synchronous. We'll see on the screen a difference between a table of the difference in which an interrupt an event that is triggered by an external component other than the CPU that alerts the CPU to perform a certain task. So whenever the interrupt occur, a CPU has to stop the current execution and gives the control to the requesting device. Whereas in the polling, an activity of the sampling a status of an external device by a client program as a synchronous activity. This is an synchronous activity in which a CPU continuously monitors, and if there is an activity, it will give the control to that device. When an interrupt handler executes, okay, in the polling, the CPU provides the service, whereas the interrupt demands the service. In the polling, a CPU provides the service, whereas in an interrupt, it will demand the service. Interrupt can occur at any time, whereas the polling can occur at a regular interval. Interrupt request line indicates that the device needs a service, whereas a command read bit indicates a device. In the polling, a command ready bit indicates that a device needs the service. In the interrupt does not waste much cycle, because whenever the interrupt arises, a CPU gives the control to that interrupt. That means there is not a much more CPU wastage of the CPU cycle. But in case of the polling, it continuously or periodically monitor for the devices. So if there are 10 number of the devices in the queue, and it CPU monitors the first one, second one, third one, and if the fourth one raised for a request, it will give the control to the fourth one. But first three cycles are waste. So in this, in the polling, a waste of the CPU cycles is much more as compared to the interrupt. In the interrupt, it is inefficient when a device interrupts the CPU frequently. Why it is said that it is an inefficient? Because of the interrupt, whenever the interrupt occur, a interrupt handler executes the instruction. That means it demands from a CPU the control, and CPU at that time or a microcontroller at that time stop the execution of the current process, gives the control back to the requesting process. So this interrupt will stop the current execution, and this will not an efficiency. This is not an good to improve the efficiency of any machine. If any machine works for a particular task and any other task will interrupt for that, and a microcontroller or a CPU needs to give the control to that particular task, this generates an inefficiency for that particular task. So in case of the interrupt, it is an inefficiency when it requests for a CPU frequently, whereas in case of a polling, it is also inefficient when the CPU rarely finds a request from the devices. As we know that in a polling, a CPU or a microcontroller continuously monitoring for a device, is there any request from a device? As previously we discussed that a number of 10 devices are connected in a view line, and a CPU or a microcontroller continuously monitoring for the their request. That means they waste the CPU cycles they are for wasting. So this is also a inefficient way. So this is in all how the difference between an interrupt and a polling. So thank you for watching the video.